In this video, I'll cover all the basic combinatorics you would ever need to know for the probability section of AP Statistics. So let's start basic with that of phone numbers. So a phone number is just a string of 10 digits, 0 through 9. Now, how many possible phone numbers are there? For the first number, there's 10 possibilities. It's going to be 0 through 9. You could repeat, so it's going to be the same thing for every single one of them, down to the last one. So 10 times 10, 10 times. It's going to be 10 to the power of 10 possible phone numbers. Not very interesting. What if we couldn't repeat numbers? Then you'd have 10 possibilities for the first one, but then you wouldn't be able to choose that number, so you'd have 9 for the second one. That would eliminate another one. Then you'd have 8 for the next one, and then it would be same thing all the way down to 2, and then you'd be forced to pick the last one. And this is the formula for 10 factorial, which is going to be everywhere because this is the number of ways you could order 10 things. Okay, let's get even more interesting. How many unique phone numbers can you make if phone numbers were 3 digits long? And you could not repeat. If you could repeat, it would just be 10 times 10 times 10, but who cares? Now, you'd have 10 possibilities for the first one, 9 possibilities for the second one, 8 possibilities for the third one. That would make 720. Now, to get into some of the things that confused the shit out of me when I first did this, 720 is just 10 factorial over 7 factorial. Why would I do this? This is the same thing as 10 factorial over 10 minus 3 factorial, right? And this is true because the numerator becomes 10 times 9 times 8, all the way down to 1. And the denominator is going to be 7 factorial, which is just going to be 7 times 6, all the way down to times 2 times 1. And then the whole denominator is going to cancel, and then everything in the numerator but the 8 times 9 times 10 is going to cancel. So this is true. Why would I do this? This is the form of the permutation. So this is equal to the number of permutations of 3 objects from a group of 10. And it's of the form 10 factorial over 10 minus 3 factorial. Okay, here ordering matters. So if you had this phone number, it would be different from this phone number. Right? Okay. Let's get even more interesting. Say you're in a circle and bottles start spinning. And there are 10 people in said circle. And everyone's by. How many groups of 2 can you make? Alright, so the first person, you're going to have 10 possibilities. Now, that leaves 9 people for the second person. But is there really going to be 90 different combos? What if you picked person A for the first person and person B for the second person? Would that be any different from you choosing B first and then A second? No. So each unique grouping is going to be repeated twice within this 90. So in reality, you're going to have 90 over 2, which is 45 groups of 2 amongst this group of 10. And this introduces the last thing, which is the choose function. So this could be written like this, or it could be written like this. In either case, I don't like this one, it's going to be n factorial over r factorial times n minus r factorial. Okay? Now, why are we dividing by why are we dividing by r factorial and not just r? Right? We're going to get a spicier example that'll make it clear. So imagine it, instead of groups of 2, we're doing groups of 3. So we get 3 slots, 10 possibilities for the first one, 9 possibilities for the second one, 8 possibilities for the third one. And there wouldn't be a difference between picking A first, B second, C third, then C first, B second, then A third, right? But how many orderings of A, B, and C are there? That's just going to be 3 factorial. There's 3 to choose from. So it's 3 factorial. Okay, so if ordering didn't matter, it would be P 10, 3, number of permutations of 10 objects into groups of 3, but ordering doesn't matter, so we divide through by 3 factorial. Now, using the formula from earlier for the top, you would get 10 factorial over 10 minus 3 factorial. Oops. And then the denominator, you'd have 3 factorial, and then you would just get, let's see. 10 choose 3. You choose 3 people from 10 choices. You would get 10 factorial over 3 factorial times 10 minus 3 factorial. Right. And that would be 720 divided by 6 would be what? Let's see. 720 divided by 6. You would get 120. 120 different groups of 3 from 10 people.